All right, welcome everyone to this pre-recorded webinar on coding SMBI. I'm Ed Hayes of ODOT Central Office. This webinar is intended to give you a good starting point into the inventory. As you read through the manual, you are going to see a lot that I'm not able to cover here in our limited time. So I will be doing one comprehensive example with some tangents, and then I'm going to show a more complex feature and routes example. One thing I want to say is that we really want to encourage everyone to check every field. The data that was translated over from SNBI or over from NBI is only as accurate as it was, originally coded. So here is the bridge that we're going to use for our comprehensive example. First thing I do when I am inventorying the bridge is I come down here and I will get my GPS coordinates and I will put those into Google Maps. So if we just put those in, it'll take us to our bridge. So one thing that I'm noticing right off the bat is that our log points, our GPS points, all of our points on our bridge should be at the rear abutment. So right off the bat, I have a tip off that we might have some inaccurate data in our inventory. The second thing I'll do is I'll put those GPS coordinates into TIMS and pull up the bridge there, because that's what we're going to use for a lot of our inventory fields. Now when we're on the asset page here, we do have a link to TIMS that you can just copy and paste. However, right now this still brings you to the old TIMS, and as that's going to be phased out, I'll go ahead and show you how everything looks in the new TIMS. So if I'm in new TIMS, we do have a map viewer for you to use. Under structures, and this kind of top right box up here, I can paste in my GPS coordinates and it'll zoom me in on the bridge. Now this is a great layer that it starts on, especially if you're looking for waterway names or street names or things of that nature. My personal preference is to use the satellite imagery, which is just this next one down. If you click on this field here, it'll give you your base maps. So all right, so I've opened up a report here that we can do this inventory off of. You can obviously use either an open report that you're working in actively or asset values to do this. For this example, I have a dummy report open. Let's pretend, we've gone out, we've done our inspection, and now we're verifying that all of our inventory is correct. All right, now what I've done here is selected a bridge that has your typical transition of data from NBI into SMBI. So this is what most of your data will look like when you are getting into these bridges for the first time since SMBI updates have gone through. All right, so these first four fields that have data in them are usually pretty correct, right? Our bridge number, bridge name, state, and county. Next on the list is place code, but since I noticed that those GPS coordinates seemed a little off, let's go ahead and verify that in TIMS. So if I go under structures and I click on my full bridge inventory, it'll drop the pin of where TIMS thinks the bridge is, or where TIMS is pulling the bridge to be. And again, we wanted that point to be on the rear abutment, so we do have some inaccurate data in there. So the easiest way to pull off the correct GPS coordinates is to go to Google Maps. You can right click on that rear abutment, and down here at the bottom, it'll give you perfect 6 digits for your GPS. You can copy those out and paste them in. All right, so with that done, let's move back up to our place code. Now these actually usually came in pretty correct, especially if it's just in a township, this TWP. One thing that doesn't always get picked up is if our bridge is in a municipality. So to check that, we'll go back into TIMS, we'll go under boundaries, and we'll go ahead and click on cities and villages. So here we have nothing displaying, didn't change our screen, which means probably not in a municipality. we zoom out, you'll see what that looks like. If our bridge had been in a municipality, it would have been inside one of these yellowish orange or grayish boxes. And if I were to click on those, we would see in here, it would give us our FIPS code. And in asset-wise, we could then select from our list the correct place code. These are just alphabetical. The numbers correspond alphabetically to your location if you're trying to navigate to one of those. Oops, didn't want to do that. That's fine, we'll fix it here in a second. So if it was in a township and that wasn't in there, there is another layer for that. So we're at our bridge, and we can unclick cities and then just click on township. And in the middle, it'll give us the name. And if we click on it, it'll give us the FIPS code. So let's go ahead and get that FIPS code back in there. All right. All right, next up, district. Again, usually comes incorrect. We know that Fayette County is in District 6, so we're all good there. We did our lat and long. Border bridges. This bridge doesn't border another state or another country, so we want to put an N in there. Now, when we do that, these next three fields can remain blank. And that's a new thing in SMBI where we'll have blank fields. You know, I think the intention here long-term from FHWA is to have a system where, you know, blank fields would gray out or not display if certain other, you know, fields are checked or not checked. And eventually maybe we get that functionality in Bentley, but not at current time. So our next field here is bridge location. Now this is often wrong. It's a very old field that we don't really use anymore, so it can be very out of date. So a good way to check it is just to hop into Google Maps and see if it looks like it's accurate. So, you know, 5 miles-ish south of my bridge, I should see State Route 238. So I'm scrolling down, and what I'll come across is State Route 38. Well, that's interesting. Let's go ahead and measure the distance to our bridge and see if this is the route that should be entered in there. So to measure in Google Maps, we're just going to right-click. At the bottom of this list, we'll have a measure distance. It'll drop the first pin where you right-clicked, and then we can click on our bridge, and it will display our distance. 5.15 miles. So probably either this route name has changed over time or this was entered in inaccurately. Now, another thing about this field is it used to be pretty restricted with the number of characters we could put in there. This field gives us plenty of characters to use now, so we don't necessarily need all these abbreviations. So let's go ahead and clean this up. 5.15 miles. .15 miles northeast of the junction with State Route 38. All right, our next field is Metropolitan Planning Organization. We also have a field, a layer for this in TIMS. It is also in the Boundaries tab. What is the top here? We'll see Metropolitan Planning Organization. Toggle that on, and again, we're not highlighted here, which kind of indicates to us we're not in one. But if we were, we would see one of these colored borders. We'd be in one of these colored borders. So if we were, we would just take that lettered acronym there, and we would type that into our field. Now we do have the option, if we want to, we can report the Regional Transportation Planning Organization that the bridge resides in. This is optional. If your jurisdiction wants to do it, feel free. And again, you would just record your acronym of the RTP. Right now, we're not tracking that information for RTP, so we'll just put an N in Metropolitan Planning Organization. Next, we have interstate mile marker. So if our route on the bridge were an interstate, we would take the state log point for that bridge, and that's at the rear abutment. And that process for doing that is very similar to our county log point. So we'll show that when we get down to highway features. Classification, you're going to need your RIMR or your agreement documents to, if you need to make any changes here, to verify those. On our right, we have federal or tribal land access. So this is going to be if a road, a bridge in our jurisdiction is, in a national park, in a U.S. forest, or there have been a few instances I've seen where our bridge goes over a dam that's operated by the Army Corps. Historical significance is a field that's actually maintained by someone here in central office. But if you did want to verify, there is a layer in TIMS for it. That's under assets. You'll see historical bridge inventory. And you would see a little yellow shape pop up that would let you know with some information there. Okay, let's move on to toll. So this field is for, again, our route on, right? So the first two fields is if the actual bridge is a toll bridge. And then the next 2, 3, and 4 are for if the route is a toll road. So this is going to come into play a lot for our Ohio Turnpike friends. Next field is emergency evacuation designation. The state of Ohio doesn't define any emergency evacuation routes. So for us, we can put an N. Now, if your jurisdiction does, feel free to code that as yes if that route happens to be on that designated evacuation route. Our next field is MBIS or no for bridge, and this is if the bridge is applicable to MBIS. So we're looking at 20 feet or more and carries vehicular traffic. So our railroad over or pedestrian over bridges would not apply to this. And the way this field was transferred over, you will see some yeses that should be no's, especially for those railroad bridges or pedestrian bridges. So make sure you're checking that field. Section 2, bridge material and type. Before getting into section 2, I like to take a look at the pictures. Just to get a feel for the bridge, prepare for what we're doing. And obviously, if you don't have plans for your structure, you're going to be doing your entire inventory off of pictures and field measurements. So quick look through our pictures. We see we have an asphalt wearing surface. We see we have what looks like pile bents, some sort of an abutment here, and I'm not seeing any obvious coating on those concrete surfaces. Looks like we got box beams, some sort of steel encasement on our piles for our piers. All right, and now we'll jump back into that inventory. All right, so for this structure, we do have plans. So we'll be using that for a lot of our fields. So the first thing it's going to ask us is span type designation. We can see here we have 3 spans that are pretty much the same. The length of the span might be a bit different, but our configuration doesn't change from span to span. So, of our options, we have main, approach. Approach is just kind of a, you know it when you see it type of a case. The only spelled out definition for an approach slab is going to be slabs over vaulted or cellular abutments. And widening, just to touch on that, we only need to use this if one of our fields below is different than the rest of the bridge. So for instance, if we had a original, the original portion of the structure was riveted girders, and we widened that with rolled girders, then we're going to need to display it as a widening type. Otherwise, it could all be under either main or approach, whatever that is. So we will use main for this. We saw we had 3 spans. If we look at our plans, we see we have a symmetrical plan given to us. We would have 11 beams. And then we will move into our first kind of temporary field. So when the translator transitioned from MBI to SMBI, it got a lot of data, right? But not all of it. So for this, it knows that it was a pre-stressed concrete, but it doesn't know if it's C3, 4, or 5. So what are those options that we have here? We have pre-stressed, pre-tensioned, so our traditional, pre-stressed, cast and placed, and then post-tensioned. And then we have precast and then post-tensioned. So we know for this, right, traditional box beams, that's pre-tensioned concrete for that. All right. So continuous span continuity can be a little tricky whenever it comes to continuous for live loads only. We do have some guidance for that in the manual on page 136. If you read that, basically what we'll come down to is kind of need to ask the load raters or look at the load rating and see what they used. So let's say we've done that and they've confirmed that this was modeled for simple spans. All right, box beams again, temporary code. It knew it was box beams, but there wasn't a way for it to know if they were adjacent or spread. And we know we have adjacent for this structure. So for protective coating for the span, we're coding the predominant type. The tricky thing here can be our admixtures, right? On page 141 of the manual, we do give some guidance here of typical admixtures used in pre-stressed members. This bridge was built prior to in the 70s, so these won't be applicable. And in any case, we want to code the outermost layer as well as the predominant layer, right? So we see here that they applied a waterproofing membrane to this structure, and so that will be our span protective system. We are going to, again, predominant coating, right? So we want to be neglecting when our fascia girders are either sealed or painted. Typically you'll see those on plans, right? You'll have kind of like a little line coming like this and be like, we've sealed this with epoxy urethane, or we've painted the fascia girders, but not the inside girders of weather and steel bridges. So we want to use predominant type in cases like that. We would code N if that's the only protection that was provided. And again, when in doubt, we want to code N and not unknown. We want to use the most conservative assumption in our data if we don't know. So we would use N if we can't verify there's anything there. Deck interaction, this can come in incorrect a lot of times. We call our box beams without a deck non-composite, but in reality it's integral and monolithic because those, the beam is the deck and the superstructure. And that is the case here. And I will also say composite shored construction is very rare. So if you're between two composites and you can't find in the plans if it says it's shored or unshored, it's most likely it is unshored construction. Our deck concrete type for an integral beam, it's going to be the same material because it is the same member. In the past, some people have said, well, there's no pre-stressing in the top flange, but the unit is the same and the unit is pre-stressed. Wearing surface, we would select our wearing surface. We have asphalt, so bituminous. Deck protective system, again, because where I am, it's going to be the same here. Otherwise, we would look at our plans and our specs for admixtures and then code the outermost layer. Deck reinforcing system. So this is rebar. Is our rebar coated, and what is it coated with? We do give, again, similar to the admixtures on page 155, you'll see we do give some years of common coatings applied to rebar. And as I've kind of stated before, if the plans don't call it out and we're not looking in the specs to find it, and we can't find it, we want to assume none for our coating. Now, again, this was in the 70s. It doesn't call out that they coated any of the rebar in the box beams, so we will assume no. There's no protective coating. All right, obviously for this bridge, we're not going to have stay-in-place forms. There is one kind of, it's almost a gotcha in the SMBI inventory. So if we use deck panels, precast deck panels, and then pour a cast-in-place deck over that, they want us to code those panels as stay-in-place forms. Even though structurally that may not be the case, that is how we want to code those, and then these fields up here would be for our cast-in-place portion of our deck. Our additional wearing surface description is to capture our SDC, UHPC, and chip and seal overlays. So if we had either of these first two, we would have coded our wearing surface as concrete other, CX, and then we would choose our SDC or UPC. If it happened to be chip and seal, we would keep it as bituminous and just also select chip and seal. Our next three fields here, hopefully self-explanatory, but make sure you're checking for that wearing surface. If they've come through and put another asphalt overlay, very common for your thickness to have changed. One thing looks like I skipped over is speaking of checking to make sure, speaking of checking things for your deck, one of our protective systems is sealer. So we want to be, regardless of what else we might have in there, as soon as our deck gets sealed, that's usually going to be our outermost layer. So we want to record that in there. Section 2.2, substructure material. So again, from our plans, we see we're going to call this a stub abutment, and then two pile vents. So we'll have two configurations, one for our abutment, one for our pier. Because those are the same, we don't need to have a second abutment type or pier type. So real quickly, let's touch on the difference between our vents and our piers. We look at our options down here. So colloquially, right, we call them all piers here in Ohio, but structurally, we're calling, piers kind of have like a connected footing where the vents do not. So a lot of our larger bridges, they might look like they have column piers from the surface, but when you get back and actually look at the plans, you're going to end up with column vents. So that's just something to look out for. And speaking of our pile vents, they are a little weird, where the substructure material is really the cap of your pile vent, because those piles themselves are the actual foundation, even though you can see them visually. So for both of these, we know they're reinforced concrete for our main material. Right, the abutment we're going to call stub. We got pile vent here, and then protector system. So again, we're looking at the concrete for our pile vent. So we can look at our plans and see if they've been sealed or if they've had admixtures. Typically, that'll be if they've applied a sealant, you might see it visually, or they might kind of have, if you can see my cursor, they might kind of like draw like a little line here and say, seal with epoxy urethane. So we're not seeing that here, and again, the pictures didn't show anything, so we'll code none. Foundation types. So let's look at page 180 of the manual. So one thing we want to make sure I distinguish here is if our concrete is reinforced, then we'll call it a concrete pile. Otherwise, it'll most likely be a steel pipe. So for this situation, a lot of times that reinforcing is specifically called out in the plans. They'll actually show the rebar, and they'll even give you a little bit of a note about the encasement. Not on this particular bridge, but we do see here that they're calling out reinforced concrete. They also call it out again in the bill of materials. So because this is very common that these are reinforced, especially for this time period, I think we're safe to say that we have reinforced concrete piles for both. Now we saw visually, again, it didn't list it in the plans, but we saw visually that we had a steel encasement. So for our pier, we'll code that as encasement other, right? Our concrete is going to be if we have like a concrete and PVC like encasement around like H piles or something like that. So it's going to be EX. Now again, our plans didn't call out any encasement, and we can't visually say that there's an encasement of the abutment piles. So we're going to be conservative and we're going to say that there isn't one. All right, let's do some tangents here. So again, we want to be coding the most conservative case. So for our foundations, if we don't have the plans and we can't see it, we don't want to be coding those as unknown. We want to be coding them as the most scour susceptible abutment type, and that is going to, or foundation type, I should say, and that is going to be a footing not on rock. And to be consistent with that assumption, even if our bridge isn't over water, if we can't verify that it's on rock, we'll say that it's a footing on soil, which is not on rock. So this usually means we're going to need plans or construction records to verify this. Now I have another bridge here pulled up that does have this scenario. Usually that's going to be listed in your notes. It'll give you a call out about what happened with the footings. We can see here Pier 3 in the forward abutment shall extend 3 inches in the bedrock or the lower elevation. Sometimes you'll also find that information called out on the substructure detail sheets. So an interesting case here is that means we end up with this different bridge, right? But we'd end up with two different configurations, and I'll show you what that would look like. So here, right, we actually have two abutment configurations because one has a footing not on rock and one has a footing on rock. And same with the piers, right? We get two different configurations because some of our piers are founded on rock and some of our piers are not founded on rock. So that's how that'll play out if you run into those scenarios. And speaking of substructure things, culverts. For 3 and 4 sided box culverts, they being FHWA, wants us to code a substructure. It's not really substructure, but that's how they want us to do it. So 9 times out of 10, right, we're just going to have 2 abutments that are wall abutments with footings not on a rock. If you have multiple barrels, you're going to code that middle wall as a pier, but again, pier wall probably not founded on rock. So keep that in mind. That is a little odd. If you have pipe culverts or another shape of culvert, then you can leave substructure material blank. All right, now roadside hardware. I'm sure there are a ton of questions on roadside hardware. It is definitely one of the harder fields to code. It probably deserves its own session, so we're not going to go into it here. But I will show you where our manual, our kind of guidance document on coding those is. So if you're an AssetWise, go under help, go under documentation. You'll see down here, we have an item for coding the railing. You can download it by clicking this button here, and you'll get a PDF, nice fat PDF, over 100 pages that'll hopefully give you some help into coding that. Moving on to section 3, geometry. The first thing you might notice as you're looking at this is that a lot of our numbers are off by like 0.1. That's just something that happened when we transitioned over from SMBI, but we want to be checking all these fields anyway. So our decimal places, one decimal place for all of these, even if that decimal is just a 0. So I like to start with total length. If you have the plans, it's a really easy one to pull because it is just the bridge limits, which is usually listed on our kind of cover sheet of the bridge plans. Then I'll move up to MBIS bridge length. So this is typically just our clear span or our face-to-face of abutments. So if you have plans, you can just subtract the distance, the distance between the bridge limits and the face of the abutment. I'll show you what that means here. So our bridge limits go basically to the approach lab in here. So we've got 15 inches between the bridge limits and the face of the abutment. So 30 inches, 2.5 feet. If we subtract that, we get 126.7. Minimum and maximum span lengths are, again, if you have plans, pretty easy because they will be listed on that cover sheet where they're describing the structure. It'll give you the length of each span, and so you'll just record the longest and the shortest. Now, if our spans are all the same length, or we just have a single span bridge, we still fill out both these fields. They'll just be the same number in both of those fields. And keep in mind that all of these lengths are along the center line of the roadway. So this comes into play a lot when we have a sub 10 foot or 20 foot culvert, that when you actually measure that opening along the center line of the roadway will end up meeting Ohio or national bridge lengths. All right, our deck out to out, for a bridge like this with deep beam guardrail, they're generally the same, as long as that guardrail is still flush with the edge of the deck. So from our plans, we see we got 22 feet, and again, this is a half plan, plus fit up. So we can put in 44 feet and then field measure to verify that the fit up didn't add too much extra length. No curb or sidewalk on this bridge. All right, roadway, approach roadway width. I have seen a lot of errors with this one, so I do always check. And I use Google Earth to check this to see if the roadway narrows or widens at the bridge. I'll drop my little man on the bridge, and you can kind of see here, right? We don't have paved shoulders, so our approach roadway width is narrower than the bridge. So this is something we can verify in the field, but to get a number in there for now, we can measure our distance. I'm getting about 29 feet. We can be conservative with that. Put in 29, and then we can field verify that later. No median on this bridge, right? No skew. It's not curved. Maximum bridge height is a field that you pretty much have to verify in the field. So I a lot of times just leave that blank instead of trying to guess. Do you remember for this, right? That is just to the water line. You don't have to get it down to the creek bed or whatever it may be. Not a side hill bridge. I don't even know that we have any of those in Ohio. And then irregular deck area only needs to be entered if the calculated deck area, which is total bridge length times bridge out to out, is incorrect. So like if we had a flared structure, then we would need to fill this out. And speaking of flared structures, for our out to out and for our curb to curb, we are doing the most restrictive. Next section is features, and this is kind of our big one with SMBI, right? So as we start at the top, feature type, most of these are self-explanatory. Urban features a little ambiguous. That's going to be playgrounds, parks, parking lots, buildings, things of that nature. Location, somewhat self-explanatory again. We got top level and lower level are going to be used if it's a double-decker bridge. So each divided travelway is going to get its own highway feature, and I'll show you more on that in our next example. Every other feature was one per location. So for instance, if I have one sidewalk on the bridge and then one sidewalk below the bridge, each one of those is going to get its own feature. But if I have two sidewalks on the bridge, then that can just be recorded into one feature. All right, moving on to the feature name. This is a big one to check. Our old inventory kind of really only recorded the inventory route. So it's important to check if there are any merged routes. So we can do that on Google Maps. We can see right here, we've got US 63, US 62, State Route 3, and then it'll tell us if the road has a local name here. Right now it's just telling us 62, so this is just, US 62 and SR3. And we'll separate those names with the bar symbol there. All right, so for this name of the creek, I find all caps to be a little annoying. So I will spell this out. Mentioned this at the top, but a good way to check your waterway names is on the space map here. Taking the ODOT base map. Not uncommon for the names of these creeks to have changed since these structures were built. So that is a good place to check. That way, you're looking for these bridges on a map, easier to confirm that it's there. So this will be, all right, speaking of names that aren't necessarily accurate, railroad names are one that you're going to want to check. There's a lot of incorrect information in those fields, like Conrail or B&O still being listed, which don't even exist anymore, or the tracks may have been abandoned. So we do have a layer for this in TIMS. We're under assets. We can use, I'll go ahead and, well, I'll keep that open. Rail lines is our layer. You can see here we've got one highlighted, and if I click on that, it'll tell us our railroad name is Indiana and Ohio Railway. If you want to list, who has trackage rights, go ahead, but for our field name, we want that to be the railroad name so we know who to contact. And this layer will also show you, I think there's one down here, if the rail line under that bridge has been abandoned. It'll just tell you it's abandoned. So that is that layer. All right, back to highways. Our first field here is functional class. A lot of these next few fields are going to come from our roadway information kind of category. Functional class shows up here. Let's zoom back in on our bridge. So this one is not a click on to get your information. This one will use the legend, and that's up here. It's this kind of 3 dash symbol. Bring up the legend. It'll tell us that that green color right there is a minor arterial. So we got that in there correctly. Now, urban code, I'm not really sure why FHWA decided to place this here, but here we are. So what we want to use for this is our, well, we have a layer in TIMS under boundaries. We want to be using the adjusted urbanized areas. So if I were to click that on, and you would see again, a kind of like a highlighted boundary. If I zoom out, I'll show you what those look like. So if you clicked on either any of these areas on the map, it will give you the urban area code. Now, when our bridges aren't in an urban area, we code 5 nines, which is what we have here. There is one caveat, and I haven't found any cases of this in Ohio yet, but I'll cover it. If you do have an urbanized area with a population greater than 5,000 that doesn't have a unique code, this last 9 here would be coded as an 8, so you'd have 99998. However, that is not the case here. All right, so moving on to NHS, really easy to pick that up from our roadway information. We have a layer for the NHS. Again, didn't highlight anything here, but if we were to zoom out, you would see we'd get a big old red line on our route if it was NHS, yes. The National Highway Freight Network, again to the layer. Remember, this is not the old National Truck Network. This one, you'll have a purple line on your primary routes. And the other thing you'll notice is that not every portion of an interstate is on the primary freight network. So if you see here, we're missing some of 670, and up here we're missing some of 77. So we look at our options, right? We have primary highway freight network, that's our purple lines, and then any interstates not highlighted purple are going to be number 2. Now, 3 and 4, we don't have any critical freight corridors in Ohio at this time. For this bridge, it's a no though. So similar process, right? For StrawNet, we have a layer. We can turn it on, and if we zoom in a little bit, it'll highlight those for us. Our StrawNet routes will be this kind of pinkish red color, and then our connector routes will be this orange color here. It corresponds to our options. But again, not for the bridge we are currently looking at. All right, so our next field is LRS route ID. This is just the NLF ID, and it usually comes in right, but you can see here that that is not an NLF ID. So there's a bunch of fields you can pull this off of. I generally just pull it off of the road inventory. If you left click on that, you'll see listed your NLF ID, and we can just copy and paste that out of here and into here. Okay, LRS mile point. Again, we want to take this at the rear abutment. It's our SLM, but a lot of times our inventoried name SLM is a little bit off from the current mile point, either because things have changed over time, or this particular field, they want 3 decimal points. So that also changes some stuff. To get that, if I'm on my map in TIMS, I want to go to my rear abutment, and I'm going to right click. We'll drop a little pin there. You can click on location information. And down here, it'll give you the state mile log if you needed that for your interstate. But for this, we want, for all of our fields under highway features, we want county log. So again, we can copy that out and paste that in here. It'll get upset because there's a space up here, and that's fine. We just get rid of that, and it'll be happy. Lanes on highway, something self-explanatory. If you do have, merging lanes, ramp lanes, center merge lanes, or center turning lanes, we do count those if that lane is full width for the entire length of the bridge, or the entire time it passes under the bridge. All right, ADT and ADTT, they can be a little tricky, as I'll show in the next example, but if you have a non-divided route, they are pretty simple. In TIMS, under roadway information, we're going to want to use traffic count segments. You'll see we'll get a colored line on our bridge, or that color is just kind of like how much traffic there is. And then we can pull off our year, our total ADT, and our truck ADT. Now this will almost certainly not be up to date, so that is something you will need to update. All right, our next 4 clearance fields I'll talk more about in the next example. I'll just note now that, our vertical clearances on the bridge are typically going to be controlled by something like sign structures or light poles or overhead utilities. And our difference here, between maximum and minimum in a case like that, if our sign structure doesn't go overhead the full width of the bridge, then we'd have one area where we have unrestricted. So maximum usable would be 99.9. And then that area obviously under the sign structure would have the minimum vertical clearance. Now this maximum usable vertical clearance is only required if the feature, this column here, is NHS yes. Otherwise, we do not have to report that. All right, for routes on a bridge, also, I will note that for routes on the bridge, our left and right clearances can be are supposed to be left blank. All right, maximum usable width is usually just our curb to curb. If a structure is flared, we're going to use our most restrictive opening. I think this is something we'll be clarifying, but we do, for our permitting processes, we do need this horizontal. This is essentially horizontal minimum vertical clearance, so we do need this for all of our structures, not just NHS structures. Moving on to the bypass detour length. The definition of this is the same as MBI, but it's a little odd, so we'll go ahead and take a look at this. This is our net mileage to actually bypass the bridge. So I usually check this using Google Maps. So if this were a non-state operated route, we could simply take whatever route gets us around this bridge, whatever route gets us off of the route, around the bridge, and back onto the route. So for instance, I would go up in here. And so we could use our Google measure by right-clicking and measuring distance to kind of get us that mileage. So we'd have 4.9 miles, and then we would subtract that from the mileage if the route was still available to use. So we would get rid of these. We'd subtract that from 2.8. That would give us about 2, right? Now, one tricky part though is that we can only detour interstate US or state routes onto other interstate US or state routes. So this one becomes a little bit more complicated. So if I zoom out, it looks like I have maybe 2 options here, right? I can send them down 38 to 71, and they can kind of swing back down, or I can kick them out on US 22 and have them cut back in on State Route 207. So for this one, since it's a little bit longer, I like to use the directions feature of Google Maps. So if I just left click on the map, I can click this direction symbol, and it'll give me directions from where I am. But if I go to this field up here, delete out my location, it'll let me click on the map where I want to drop that pin. And so you can see there, it'll give me the original length of the route, 11.1 miles. So then I can click on this blue line and drag it, and it will kind of snap to the next route that makes the most sense. So it snapped to that route I was talking about, and it's given its distance right up here, 21.1 miles. So we can subtract that out, and that detour would be about 10 miles. So let's check that other one. So that other route option starts down here. If we cut them off on 22, gives us original mileage of 15.5 miles. And then I can again click and drag, and eventually it'll snap into that route I want. And then I can, subtract that original mileage from this number, and I'll get about 9 miles. So my bypass detour length is the smallest one of those two, right? So you can actually bypass that bridge in 9 miles. So that completes the highway features here, right? We do have one field that needs to be completed under the waterway feature, and that is if the waterway is navigable. And I will tell you, the overwhelming vast majority of structures in Ohio are not navigable. I mean, we're talking like tens of bridges that are, and we have some guidance in the manual that will help you determine that if needed. Okay, routes. As I mentioned earlier, most of our routes were only inventoried for one route on and one route under. So many cases we'll have to add in those other routes. So for this one, right, we had US 62 and State Route 3, and they both are on the same. They both are, traverse the same highway feature. Now, route direction is how the highway is signed. So 62 is signed as an east-west route, and State Route 3 is signed as a north-south route. If I didn't know, I could do a quick Google, or if my route isn't signed in any specific direction, I would just choose the most applicable direction. So every highway feature must have at least one route assigned to it. And so if that route happens to be a municipal route, those only need to be reported if it is the only route on the bridge. And so what I mean by that is, I guess not what I mean by that, but why I say that is a lot of times when we inventory those municipal routes, right, and asset-wise, we kind of put in the name of the route and kind of put an abbreviation in there. But in routes, we want to actually put in the route number, even if that's not something we use colloquially. That's what our backend data is going to pull from. So you would get the route number for those municipal routes. But again, we only need to put those in if it's the only route on the bridge. More to come on routes in our next example. So let's jump to some of our SMBI fields are still on the Ohio Bridge Inventory page. You'll see we have the priority system code up here. That's a field in roadway information. We're working on the major bridge field. You see we have the GISP up here. There's some IR and ID fields down here, and then intermixed, there are a few fields here on the right. I just want to touch on a few of those real quick. Deck concrete deck type, and steel member steel type. That information can be found on the plans. So, here's kind of your typical state bridge, right? A lot of times that information is just listed in your design data. You can see here they're calling out Class C concrete, structural steel A36. It may also be listed in the bill of materials, or sometimes, not super common, but sometimes that steel grade will actually be listed on the steel details page. The other one that I want to touch on is whether our bridge is it goes over a scenic river or not. We have a layer for that in TIMS. It's under environmental. We click on this, it will put a big, it's 1,000. This layer is for 1,000-foot buffer, right? So it puts a thick line over those waterways, but it also makes it very easy to know that those are our scenic waterways that we need to be coding. So that does conclude this comprehensive example. So the next one we're going to look into is a more complicated highway features example. So this next bridge we're going to take a look at for more complex features is US 40 over 270 in Columbus. You can even see here, looking at Google Maps, we've got divided highway on, divided main line below, and 2 CD roads connected to that, along with common names for our routes as well. So what does that end up looking like when we get all of that information coded? We get this. So it can look like a lot. It is a lot, but once you get into doing it, it's a lot of repetitive information. So we want to be, each of our divided routes, we want to make sure we're calling out the direction of that route in our feature name. Again, record those route names and common names. We may have multiple, and we're going to use our kind of bar delineator to do that. When we have something like a CD road, it doesn't really have a name. We're just going to name it, pretty straightforward name. If we have a ramp, we're going to put in ramp from, X-bound route to X-bound route will be our feature name for true ramps. For CD roads, we can kind of just put in the main attached route. Looking at TIMS, right? If we're looking at our roadway inventory, it's going to show us that each one of these lines has its own NLF ID. So, our C, the only thing that's different for some of them might be C and N, cardinal, non-cardinal. That's going to be for our routes. Ramps and CD roads are going to get a random number assigned to them, and they're always going to be listed as like the cardinal route for those. When we're doing mile points for routes under a bridge, we're going to go ahead and take it at the center line of the bridge. So for this CD road here, we would just go to the center of the bridge on that line. We would right-click location information, and we're going to get that county log point to 3 decimals. You will notice sometimes that even for your cardinal, non-cardinal routes, that those 3-digit mile points might be a little different from each other. They're not necessarily going to be the same just because they're right next to each other, as you can see here. So clearances, right? This is where we get tricky, especially for our vertical clearances under. Our plans usually give us just the minimum vertical clearance, and that is just going to be for one of these features underneath. So for this particular example, that ended up being, when I looked in the plans, it was for this southbound CD road. And unfortunately, that means we're going to have to find a way to get all the rest of these clearances measured and input. And that's going to be vertical, and for our routes under, our left and right clearances. So TIMS, or I should say ADT for divided routes. Let's see what that looks like in TIMS. So you'll see that TIMS will put the ADT on the cardinal route. So for something like our CD lanes, where it's not technically divided, we're good to go. We can take that information from there. But from our divided highways, for instance, 40 here, right, is divided. This number it's given me here is the combined ADT. So we need to break out eastbound and westbound ADT. And so, that's not always 50-50. If we scroll down on that field, we'll see traffic reports. You can click on view. It'll take you to the actual traffic report, and you'll see you'll have an option for eastbound or westbound. It'll give you your ADT, and your truck ADT is listed under this BC figure. And it gives you your year over here. Now, sometimes they're pretty close to 50-50, and you feel a bit silly for going to that level of detail, but other times they can be quite different. So those are good to check and get in there. Detour routes, right? We're going to be doing, we're taking these assuming the entire bridge is out, right? So our divided highway on isn't zero, just go over here, right, where the bridge is gone, and similar below. Our divided routes aren't just going to this other highway feature and go. It's we actually have to find a route around this bridge. And then I think I may have skipped over it. So yeah, maximum usable service width. A lot of times for our under routes here, I'm going to grab a quick measurement off of Google Maps to get these filled in, and then we can, when we're in the field, we can get a more accurate measurement taken. But I'm just gonna, how I do that is perpendicular to the roadway, under the bridge. This isn't necessarily going to be completely accurate, but it gives us a number to put in there for now. And we'll be conservative, right? Since I'm taking a rough measurement, I'll just put in 49. And you can see that's what I did here. So our routes, as I've said now, every route gets every highway feature gets one route assigned to it at minimum. You'll have cases where you have two, especially for ramps. Now these are, in this case, these features are CD roads. So just one feature, one route is fine, the main route that's being collected and distributed. But if we had a more traditional ramp, such as this ramp right here, every time I need to put in this feature, I'm going to have two routes associated to it. I'm going to have a eastbound 70 ramp, and I'm going to have a northbound 270 ramp route assigned to that feature. All right, so that concludes kind of this one, and I will show you another example with some interesting route configurations. Okay, our last example here is focused on routes. Again, just to show you how those can go. So over here, it's just easier to see it on this thing. On this view, you can see we have a number of signed routes converging, going over a bridge, and then splitting off again. And additionally, we have sidewalks on, trail under, obviously a creek under. So what that ends up looking like is this. So we only have one highway feature because it's undivided, and all 4 of those routes end up getting assigned to it. And so in our feature name, we again list all of those routes, and we're also going to list the actual, the common name, the street name in there. We've got our sidewalks on, our creek below, and our trail below also listed. And for features, we now have 4 routes. Again, we don't need to list that municipal route because we have other routes assigned to it. So we have 4 features for each of those routes assigned to the same bridge. So that is going to conclude our presentation today on coding SMBI. I hope this was helpful. If you have any questions, feel free to reach out to me and Jared, and we'll work at getting those answered. Thank you.